Hello students, I am Dr. Gajendra Purohit and you are watching our YouTube channel where I upload videos for engineering mathematics B.Sc. If you are preparing for any competitive exam where higher mathematics is asked, our channel is very helpful for you. Students, I have uploaded many videos on discrete mathematics. You can check those out from I tab, description or the pinned comment. Today I am going to be teaching you a very important topic in graph theory. It's called matrix representation. It means representing a graph using a matrix. So here we have incidence matrix representation, adjacency matrix representation and path matrix representation. I am going to tell you all about this. Let's move ahead. What is matrix representation of graph? We will talk about adjacency matrix and the definition of adjacency. Adjacency is like if we have two vertices connected by an edge, then those vertices are called its adjacency. Okay, students? And how do we represent its matrix? Any vertex that is connected to an edge, we will write 1 there. And if it's not connected there, we will write 0. Let me give you an example to explain it. Let's say, for instance, this graph has been given to us. We need to do a matrix representation of this. So we will write here V1, V2, V3, V4 and V5. Okay, students? And here we will write V1, V2, V3, V4 and V5. Okay, students? This is the V1. It's not self-connected. It's not a self loop. So it will be 0 here. Are V1, V2 connected? They are connected. We'll write 1 here. Are V1, V3 connected? They are not connected. Then it will be 0. So V1 is connected to V2 and V5. So wherever V1 comes, put 1 and everywhere else 0. V2 and V1 are connected, so 1 will come here. V2 is not connected to V2. It will connect when there is a self loop, right? In this V2, V3 is connected, so it will be 1 here. V2, V4 are not connected, nor is V2 connected with V5, so it will be 0, 0. Now we will talk about V3. V3 is connected with V2 and V4. So we will write 1 under V2 and V4 and zeros in the rest of the places. Okay, students? Just like that we have V4. We have V4 going to V5 and V3. This will become 0, 0, 1, 0 and this will be 1, right? Because V4 is going to V3, V5, right? Now we will talk about V5. So V5 is going to V1 and V4. So it's going to V1 and V4, right? We will write 0 under V1 and V4 and the rest of the places will be 0. Okay, students? This is its matrix representation. It is called adjacency matrix representation. Clear? Now I want to tell you that if we are given a directional graph in which the direction is given, what happens in that case? If the graph is not directed, then in that case the matrix that is formed is symmetric matrix. It means V1 goes to V2 and V2 goes V1. We'll count both. But when we have a directed graph, then in that case V1 going to V2 will be counted. In its place we will write 1. But V2 is not going to V1. In its place we will write 0. In that case symmetric matrix will not come, right? Now we will see how. I'll try to explain it. Let's say you have a directed graph here. So we have V1, V2, V3 and V4 and we have V5 that will come here. Similarly, we will write V1, V2, V3, V4 and V5 here, right? Now we will be talking about V1. V1 is going towards V2 and V5, right? There are directions on both sides. We will write 1 in the places of V2 and V5 and 0 in all the other places. Now let's talk about V2. So V2 is going only to V3, not to V1. So we will write 1 under V3 in the line of V2 and we will write 0 under the rest. Okay, students? Let's talk about V3. We have V3 going to V4 but not to V2. So wherever there is V4, it will be 1 and the rest of the elements here will become 0. Okay, students? We will talk about V4. So we don't have V4 going to V3 or V5. So all the elements here will become 0, right? So we need to pay attention to this. We will talk about V5. So V5 is going to V4, not to V1. So we will write 1 where we have V4. The rest of the elements will be 0. So when it is a directed graph, then its representation is this. But it is not a symmetric matrix. If we have an undirected graph, then in that case, the matrix representation is symmetric. Clear? Let's move on. So whenever we have a self loop, let's say if we have a self loop here or if we have a self loop here, then in that case we will have 1 here, right? I want to tell you we have V1 here, V2, V3, V4 here and V5 here. This is V1, this is V2, V3, V4 and this is V5. See, V2 is going to itself. So If we have it going to itself, then in that case, it will become 1. If we talk about V4, it's going to itself. What will we get here? We will have 1. You need to pay attention to this. If by chance here in between you have, let's say we have 2 more paths coming in here, meaning there are 3 paths coming in. V1 to V5, so in that case, the path that is going from V1 to V5, in this matrix, this will be 3 here. Okay, students, got it? And from V5 to V1 also, we will write 3. As many paths will come here, we'll write them. We need to pay attention to this. So, whenever a self loop comes, then in that case, the value of the diagonal element comes. This needs to be paid attention to. We will discuss the incidence matrix. Before that, let's understand what incidence is. If we have 2 vertex and those are connected by an edge, then that edge is called the incidence of those vertices. And its matrix representation is known as the incidence matrix. Okay, students? Let's take an example and try to understand it. Let's say we have this graph and we need to present this graph and create an incidence matrix for it. What will happen in that case? We have its vertex here and its edges will come here. In the adjacency matrix we discussed earlier, we had vertex here and we had a vertex here too. Wherever they connected, we would write 1, but it is not like that. Vertex comes here and the edges comes here. Wherever there's an edge connecting to a vertex, we write 1, and wherever they don't connect, we write 0. We tried to explain that if we have Vi, that is a vertex. If it's connected to Ej edge, then we will write 1 there, and if it's not, then we will write 0. Okay, students? And if we have a self loop here, in that case, students, we will write 2. Let's take an example and try to understand it. We have this, so if we have to build the incidence matrix of this graph, so V1, V2, V3, V4 and V5 will come. And we will write E1 here, E2, E3, E4, E5 and E6 here. Okay, students? Now listen, grab V1 on V1. What's happening? E1 edge is coming and E6 edge is also coming. So we will write 1 under E1 and E6. Rest of all the elements will be what here? They will be 0. Now look at V2. What's coming up on V2? It's E1, E2 and E3 is also coming. So this will be 1 here, here and here. Rest of the elements will be 0. Now let's talk about V3. So what's coming to V3? E2 and E4 are coming. So we will write 1 under E1 and E4 and rest of the elements will be 0. So if we talk about V4, on V4 we have E5, E4, E3 coming. So we will write 1 under E5, E4 and E3 and rest of the elements will be 0. So if we talk about V5, we have E6 and E5 coming. We will write 1 under them and rest of the elements will be 0. So this is the incidence matrix, and in this way we can understand this easily. So just imagine we have V3 here and the edge coming here is E7, right? In that case we will have a slightly larger matrix, and here we will have E7, right? So students, listen, in that case wherever we have V3 and E7, so here we will have 2 and rest of all the elements we have will become 0. This needs to be noted, okay? Because it's a self loop, so here we will count 2. This needs to be noted. Let's talk about the path matrix. It's a little bit different from adjacency and incidence matrix. What is a path matrix? If we have any graph G, which is a directed graph and its vertices are M. The path matrix that we have is P, and Bm have the same non-zero entries where Bm is equal to. Here, the Bm, that is A plus A square, that goes to A power M. Here M is the number of vertices we have. And where A is adjacency matrix. In this, students, A is adjacency matrix. So the value from the adjacency matrix is used here, and the Bm matrix that we get here is called the path matrix. Okay, students, how will we do it? I'll try to explain this to you. Firstly, we will try to know what A is. What is matrix A? A is given as the adjacency matrix. It can be easily extracted. What will come here? We have ABC instead of V1, V2, V3. We will write here A, B, C, and it is A, B, C here, right? Okay, students? A does not connect to itself. There is no self loop, so it will be 0. A is going directly from A to B, so it will be 1. A is not going to C, it is going in the reverse direction, so it will be 0, right? B is coming to A, so it will be 1. B is not going to B, so it will be 0. B is coming to C, so it will be 1. We will discuss C. C is going to A, so this will be 1. C is not going to B, right, students? C is not going to C, so this will be 0. There is no self loop forming here. Now you will say, sir, how to get the B matrix? The solution to the B matrix comes from this, and here M represents the vertices. We have 3 vertices here, correct? It will go from A square to A cube. So what will be the B matrix? The B matrix will be A plus A square plus A cube, right? But we know it's A, we need to square it, then cube it, and get its value, and then we can take it out, right? As soon as we get the value of this and the B matrix is created, where all of them are non-zero, we will write 1. And where the 0 is coming, there we will write 0, and that will be its path matrix. I will take an example to explain to you how to do it. Here we have this A matrix. We calculated its square and cube. We will get its value here, and then we'll add this. We will get the B matrix. Wherever we have non-zero, we will write 1, and where 0 comes, we will write 0. Every element here is non-zero, which means it will be 1, 1, 1, 1 everywhere, and this will be its path matrix. This is how we solve the question. If by chance we have a vertex 4 here, if we have ABC here, and let's assume that this D goes here and this is a path E5. In that case, our matrix would have been of 4 by 4. And let me tell you how would we calculate the value of B matrix. A plus A square plus A cube and A power 4 will also be there. The number of power will be same as the number of vertices. So if we have 4 vertices, then the power will be 4. If there are 3 vertices, the power will be 3, right? Now we will talk about the next question. Consider the undirected graph G shown below. Find the incidence matrix. So you have to find incidence matrix. How to get incidence matrix? Whenever we talk about incidence matrix, we will write V1, V2, V3 and V4 here. Listen, here we will write E1, E2, E3, E4 and E5. Keep that in mind. We write V1, V2, V3, V4 here. Its edges comes here. Now we are talking about V1. On V1, which edges are there? E1 and E4. We'll write 1 under E1, E4 and rest of the elements will be 0. If we talk about V2, then we have E2 and E3 on V2. We'll write 1 under E2, E3, rest of the elements will be 0. If we talk about V3, then we have E1, E2 and E5. We'll write 1 under them and rest of the elements will be 0. If we talk about V4, then we have E3, E4 and E5. We'll write 1 under them and rest of the elements will be 0. Now, we have its incidence matrix. Clear? Moving on. Next, we'll talk about finding the adjacency matrix of the graph. You have to create an adjacency matrix, right? So, in adjacency matrix, we have vertices on both the sides. Here, we have vertex in the form of A, B, C, D. So, there is A, B, C, D, and I think E is also coming here. So, this here is E, right? Okay, students? So, this will be E. So, that is also a vertex, clear? Now, what do we do here? We have vertices A, B, C, D, and E here. Okay, students? Now, A is not connecting to A, so it will be 0. Here we have a directed graph, right? So, the direction in which our edge goes, we'll write it there. A goes to B. We have A going to B, so 1 will come here. Let's see where A goes. It is not going to C. A goes to D, so we will write 1 under D. Rest of the elements will be 0 because A is not going to E. Now, let's talk about B. Where is B going? We have B going over there. So, there is no problem if E10 comes. B is not going to A, so it will be 0. B is going to itself, it is making a self loop, so it will be 1 here. B is going to C twice, so we will write 2 here. You need to pay attention to this. It is going twice. Now B is not going to D, so we will write 0 here. It is not going to E2, so it will also be 0. Now let's talk about C. Where is C going? C is going to A, so it will be 1. Okay, students? Is C going to B? No, it's not going. It will be 0. In this, C is also not going to C. It will be 0. Is C going to D? It is going. So we will write 1 here. C is going to E. So we will write 1 here. Clear? Let's see where D goes. Is D going to A? No. Then write 0 here. D goes to B. No. Then write 0 here. D is not going to C. Write 0. D is making a self loop. Write 1 here. D is not going to E. So this will be 0. Now we will talk about E. Is E going to A? No. So write 0 here. Is E going to B? No. So write 0 here. Is E going to C? Yes. Write 1 here. Is E going to D? No. Write 0 here. Is E going to E? No. So write 0 here. Now, this is a matrix representation. And in this way, we can get its adjacency matrix. Let's move on. Now, students, a graph given by the following adjacency matrix. You have an adjacency matrix and you need to make its graph. How will you do that? You need to pay attention to this. Take its vertex. I will take V1. V2, V3, V4, and we will also write V1, V2, V3, and V4 here. In an adjacency matrix, vertices will be on both sides. But if we have an incidence matrix, vertices will be on one side and edges will be on the other. So we'll have V1 and then we'll have V2 here and then write V3 here and V4 here. Okay, students, firstly, CV1. There is no self loop on V1. V1 is going to V2. 1 will come here. So from V1 to V3, we have 2 coming in. So there will be 2 edges connecting to it. Is this clear? You need to pay attention to it. From V1 to V4, here 3 is coming. So we will have 3 edges connecting V1 to V4. Okay, students, let's talk about V2 to V1. So there is one edge connecting them. Now, is V2 making a self loop? No. Let's see V3 to V2 now. V3 is going to V2. We have 3 here, so we will make 3 edges. Now see V2 to V4. V2 to V4 is given 2 here. So here we will make 2 edges. Clear, students? We will talk about this here. We will talk about V3 to V1. V3 to V1 is 2. It is connected. From V3 to V2, V3 to V2 is also connected. From V3 to V3, it is 0. And from V3 to V4, we have one connection. You can see the rest, right? So from V4 to V1, there are 3 connections. From V4 to V2, there are 2 connections. V4 to V3 is also connecting. What we have here is its graph. So we can understand it in this way. Let's move on. Write down the adjacency and incidence matrices. We need to create both the matrices, right? I will make the adjacency matrix first. Okay? I will make the first matrix here. How many vertices do I have here? I have V1, V2, V3, V4 and V5, right? We will write V1, V2, V3, V4 and V5 here. Okay? This here will be V1, V2, V3, V4 and V5. Okay, students? Now let's see its elements. V1 is not going to V1. It is not a self loop, so it will be 0. V1 is going to V2, so it will be 1. So where is V1 going? It is going to V2 and to V3. So this also will be 1 and all the other elements will become 0. Sorry, it is also going to V5. We will have what here? We will have 1 here and all the other elements will be 0. It's going to 3 places. Now look at V2. Where is V2 going? V2 is connected to V1, so it will be 1 here. V2 is also making a self loop here, so we will write 1 here. V2 is connected to V4, so it will become 1. V2 is not connected to V3 and also not connected to V5, so it will be 0. Now we will talk about V3. V3 is connected to V1, so it will be 1 here while making a self loop 2 times, right? So this will be 2. If there is one self loop, we take 1. But since there are 2, we will take 2 here, okay? Here there is no V3 to V4 or V3 to V5. So we will write 0 here. Now we will talk about V4. V4 is connected to which one? We have it connected to Vertex, V5 and V2. So in this case, we will have a 1 in place of V5 and V2 and the rest of the elements here will be 0. Clear? The V4 is connected to itself because it is a self loop. So here this will become 1 instead of 0, right? This needs attention, okay? Now we will talk about V5. So V5 is connected to V1. It is also connected to V4. So we will get 1. And rest all the elements we have will be 0. So what we have here is its adjacency matrix, right? Okay, students. Now we will discuss about the incidence matrix. Listen, here we will have a slightly larger matrix because the total number of edges we have is 9. So we have the edges here E1, E2, E3, E4, E5, E6, E7 and E8. And then we'll add one more at the end, E9, right? So this will be our matrix. Clear? How many vertices do we have? We have 5 vertices, right, students? We have 5 vertices. We will write here V1, V2, V3, V4 and V5. Now let's talk about V1. Which edges are coming on V1, E7, E6 and E1? So write one under E1, E6 and E7 right. What will happen to the rest of the elements? Those will be 0. Now we will talk about V2. We have a self loop and we also have 2 different edges. So we have E1 and here we have self loop, and whenever we have a self loop, in that case, when we have incidence matrix, we count 2 there. We need to pay attention to that. Clear? Right? You see here we have V2 and E3 is one of the edges. So E3 will become 1 and rest of the elements here will become 0. Now let's talk about V3. Now in V3 we have 2 self loops here. Okay, students? Let's see which ones are connected. We have E1, E2 and E3, but these are not connecting to V3. E4, E5 and E6 are also not connecting, right? E7 is connecting, so this will be 1. Now see E8 and E9, so these will be 2. This is a self loop, so we will count it as 2, right? Now let's talk about V4 that we have here. Which edge is connected from V4? E3 is there, put 1 in its place. E5 is there, put 1 in place of E5. And E4 here will become 2 because of the self loop, right? Rest all the elements we have here will become 0. We will be talking about V5 now. So we have E5 and E6 connecting. So wherever there is E5, E6, put 1 there. Rest of the elements are going to be 0 here. And this is what we have, its incidence matrix. So this is how we represent it. Students, thank you so much for watching me. You have to give the answer to this question in the comment box. We have this matrix. And what will be its graph and how much time did it take you to solve this? Definitely tell me. So you can watch the playlist of Discrete Mathematics from here. My new channel, where I am uploading a lot of short tricks, you can check them from here. Subscribe to the channel from here. And you can follow me on Instagram from here. Thank you so much for watching me. Like, share, and please do subscribe to the channel. Press the notification bell so that you get notified for upcoming videos. Give its answer in the comment box. Thanks.